I wanted to do a video on this problem specifically because what WebAssign keeps asking here. What series did you use for comparison? I think there should be an infinite amount of different series that could work. It's looking for one specific one, but approaching this problem, we're supposed to determine whether it converges or diverges. So we could use the limit comparison test. We can evaluate the limit as n goes to infinity of our sequence divided by some other sequence. And it's sometimes it's intuition, sometimes it's a guessing game. You could try 1 over n squared. And let's see if this comes up something that we can evaluate with the limit comparison test. We'll just first evaluate this limit, and then we'll go to the table. Limit as n goes to infinity of 5n over n squared plus 1. Now it's times n squared over 1. And you might be able to determine right now that this limit's going to be infinity, right? Because you're going to have 5n to the third over n squared plus 1. So the numerator is bigger than the denominator. This limit goes to infinity. So if we use our table, the limit goes to infinity. And then it says if b sub n diverges, our b sub n actually that we chose converges, right? This is a P series where k is greater than 1. So right there we have to stop and we have to try the limit comparison test again because our b sub n converges, it doesn't diverge. So we're back to the drawing board. Let's try something different. Let's try our good friend the harmonic P series where n equals 1. Where k equals 1, where the power is 1. Right? The book proves that the series from n equals 1 to infinity of 1 over n diverges. So I've just erased the squared. Go back and recompute the limit. Now this limit's different because you got 5n squared in the numerator and n squared plus 1 in the denominator. Now you could use L'Hopital's rule a few times. Take the derivative if you want, or you might already spot it. L'Hopital's rule again, because we can't evaluate this derivative, infinity over infinity. This is 10 over 2, so we get 5. We get one letter. We get one number. We get the number 5 when we evaluate the limit. So our limit equals some L. In this case, our L is 5. Then it says a sub n and b sub n both converge or both diverge. They both do the same thing together. Since the b sub n we chose diverges, the a sub n must also diverge because they both converge or they both diverge. So this series is divergent, but it seems like the only answer WebAssign will accept is not just 1 over n, but it has to have whatever this the leading coefficient is of the numerator, 5 over n, which also works. You could plug in 5 over n instead of the harmonic series. But to get this run right, you have to have 5 in the numerator. But technically, you don't have to use 5 over n for your comparison.